Okay, and a good morning to everyone. And it's a Tuesday morning, and this is Inauguration Day, and I hope you had a chance maybe to hear that. What I'm doing on the computer and taking just a moment to do is changing some due dates for you. I have 1-3 and 1-4 scheduled for tomorrow at 10, so that should give you today and tomorrow morning to do that on 1-3 and 1-4. Anybody need 1-2? 1-2 still needs to be done. Okay, just a moment. Trying to get that so I have those set up. It's taking me a moment to do that. Now, just for your information, this week we're doing 1-5, 1-6, and 2-1. And if you go on to Course Compass starting today, you'll be able to see the homework for 1-5.
Did you say Course Compass?
That's what it's called. My math lab is Course Compass, to give you direction.
Thank you.
You're welcome.
I need it.
1-5 is what we're doing today, 1-6 is what we're doing tomorrow, and 2.1 is what we'll do the following day. And so I've managed to get this computer so I can at least make adjustments for what we're doing. Just pass that up forward if you would please, Richie. Anybody else who's finishing up that quiz, just pass it forward please over to Robert, and he will be kind enough to put that over there. In terms of the difficulties of trying to get things time-wise set up for yourself so you have time, I realize that's being a bit of a problem. I'm trying to adjust as we go along. I just made the adjustments for 1-2 and giving you one more day in that, and we will continue to do the adjustments with the idea that you can get done. So let me show you what the time frames are that I have listed on the computer here. Okay, let's cut to the document cam, please, Jonathan. This is where I control things, and I have that set up now so that on, okay, I'm looking at the due dates. So if you look at 1-2, see if I can get that. 1-2 is coming across here, and it's listed now tomorrow at 10 a.m., the same for 1-3 and 1-4. Those need to be done. We need to get you up to date because, as I say, I'm going into 1-5, 1-6, and as it stands right now, the other thing I did, and this was because some of you are working on the computer in the lab right up to the last minute, notice I put these for tomorrow and 1-5, I have it at 11 a.m. So if you're in the middle of something right at 10, you aren't going to get knocked off. Then the next one is due the 22nd, and then the 26th for Monday. So those are the due dates on those. And okay, so that's what you'll need. Then as I come off there, and then one more thing I think I will do, Richie, if you can get yourself into the lab. Not Richie, Isaac's the one, isn't it? Who needs to catch up, is that right? Richie, are you caught up on these yet? No. Okay, get both of you going here. I'll set that to the 21st also. So if you can get those problems done, then we can get that set up. Now what I'm going to show you, I have all the homework listed in 1-5, 1-6, and 2.1 on the website. And I'm going to show you that again. And I think, Isaac, that's what you were asking for, to be able to see that, and I'll show you that one more time. So as soon as this comes up and I get this change made, we can talk about that. Questions? Jessica? There isn't a review. I don't have any reviews that I have assigned. I'm just going 1-1, 1-2, 1-3, 1-4, 1-5, 1-6, 2-1. I'm not covering the reviews.
Okay,
Kim?
we could do the test on the website, and that's not an actual test, that's for our practice?
Yeah, I'm not doing any tests on the website at this point. I will have a practice test that'll be on the website just before we take the exam, so that you can do that. So that's, okay, I'm going to change one more setting here and get that done. 121, just a moment. Okay, doing this in the fly. I thought we had things taken care of, but obviously needed more time. Okay, the last one's been done, so you have it open for 1-1 all the way through 1-4, getting caught up and getting those done. And then again, the announcement for this week is that you now show your work in a binder for each of the problems you do before you enter it. Then you have that ready at the end of the week. Loretta will take time at that point to look at your work and okay it chapter by chapter. And that's where we're going to have to come up with that one page at the beginning where you can okay it section by section. Or I should say week by week. Okay, those changes have all been done. So let me get out of there, sign off on that. And if that goes quickly, I'll show you the website where we have the material. Now let's see if I can bring up my web page. There we go. And let's go to the website again, the URL. This is where your Math 20 is in the middle of the page. I click on that, and then as we come down to, okay, I'm going to go up a little bit further, scroll down now. There's your Spring 2009 schedule. I click on that, and then what I did this morning, at about 5 o'clock this morning, I have week 2. So that's where we are. Just wanted to show you what's there. And the point being, even if you can't get on the computer, you have 1-5. There are the homework problems and the page numbers. Lecture 7, homework problems, page numbers. And in particular, as we look at the 8th one, this is a long set of problems. There are 30 problems in this one. And that'll be what you'll work on over the weekend. So just so you can see what's facing you there. It's a rather long list, but we'll talk about that more later. Okay, we can come off there, Jonathan. In terms of new material, and that's what we're doing today. We had our review on Friday, so I think we can go ahead. And the topic today is order of operations. Now, there are 4 operations that we talk about. They are the ones that we focused on in Math 10. Those 4 operations are the addition, the subtraction, the multiplication, and division. Okay, so as I go to the board. So we have order of operations. And the reason we talk about this is that in mathematics, we have problems where the expressions are quite different than what we've done up to this point. So for example, and I don't have a page number in the book yet, but it's section 1-5 if you're looking for it. 54, thank you. Okay, so page 5-4. And just a reminder, so that everybody hears this, Friday is an intended day. So that's 10 o'clock. We have our tutorial, but it's an expected one. And unless you have a job, unless you have a conflict with the class, otherwise you're working for somebody in a tutorial way, then that's okay. But other than that, you're expected to be here, and we cover reviews, and we do quizzes. And that's what we did last Friday. We'll do again this Friday. Okay? And that is also, I need to talk with Loretta as to how we're going to set up these ways so that you can sit down maybe before that tutorial and get your books okayed for the end of the week, or after the tutorial, something like that. We're going to have to set up a time for that. Now, order of operations. Let's say I give you this problem. 3 plus 2 times 5. It's a very simple problem, but it's not clear without some agreement as to what we do first. Because there is confusion, and without parentheses, we make agreements in mathematics. And there's a Congress of Mathematics, an international Congress that meets, that comes to agreements as to what you do. And the argument is you do the multiplication first here. So you read left to right, and you do the multiplication first, followed by the addition. So that means you would have 3 plus 10, and you would have 13. Now, if you didn't expect that to happen, you could tell the reader using parentheses how to interpret it differently. If I wanted you to add first, then I would place the 3 and the 2 in the parentheses, and now the parentheses comes first. Then, after you've added, you get your 5. You multiply the 5 times the 5, and you get 25. The problems can get a little bit more complicated. You remember the problems where we had the multiplications and divisions together with fractions. So I could do something like this. 3 plus 2 times 10 divided by 5. Now, again, the argument here is we are going to go in order, left to right, and see what comes first. We again skip the addition, and now we have multiplications and divisions, and the question is, does either one take priority? No. We take it first come, first serve, just like at Starbucks. Okay, so first come, first serve. And so you would say 3 plus, then you get a 20. That'd be your first step. Then you go back and say 3 plus 4, and finally get a 7. To try to explain in one nice statement, we try to do this in terms of a sentence that you many have heard. Before I do that, Isaac.
You said it had to be in order?
In order, left to right.
No, because in the high school they still taught us, please excuse my dear Aunt Sally.
Well, that's what we're going to do right now, and that was what I was getting to. It is this phrase that I hope all of you have heard, which is, please excuse my dear Aunt Sally. So we have, please excuse my dear Aunt Sally, which says, parentheses first, thank you, and then we have exponents, and then multiplications and divisions in order given, left to right, and then additions and subtractions in order given, left to right. So the idea is that you go in this direction. Now that is the classic statement. Your text has done something different. I asked Sarah about it this morning because she took 2 sections at once at the beginning, and so she covered this on Thursday. But the question, in the book they talk about roots because we do square roots. And so it's given a slightly different notation I'm going to look at. And I asked Sarah what she had done in her class, and she just had done this. And I think my own reaction is, because all of you have seen this before, I assume, or at least this, I hope, isn't the first time, that it probably makes sense just to stay with my, please excuse my dear Aunt Sally. Okay? And not include the roots as part of that. I mean, there gets to a point where I think the letters become ridiculous. Is to provide guidance. It's not like a law or something in that sense. So this is please. Okay, so that's parentheses. And then the excuse. And of course the E is for exponents. And then the my is the multiplication. Dear is the division. Aunt is the addition. And then Sally is the subtraction. So the first letters of the words are what help you. Now I'd like to contrast that to what's done in the book.
Can you say it one more time?
Please excuse my dear Aunt Sally.
No, the other thing you just said. Wait, exponents, multiplication, I got the whole thing.
Multiplication, division, addition, subtraction, in order given. P stands for parentheses. Okay, so let me go to the text. And the way that it is given in here, see if I can find that phrase. I was looking at it this morning. Now notice the phrase here, many, most, some. We had a division chair who used to enjoy saying a number of people. If one does it, that's a number. Here is the way GERMDAS. Okay, grouping, exponents, roots, my dear Aunt Sally. And the E and R together, the M and D together, the A and S with the arrows, meaning you take them in order as you go across. I don't see how that helps unless you think of germdas. germ days without the Y. So if you were to do this in text messaging, you'd probably say germ days. You don't have a Y with days. If that works for you, go with it. The only difference between that, as we come off there, and please excuse my dear Aunt Sally, is we are avoiding the question of the radical. And there are numerous examples to try to illustrate to you a way that in some sense, as I look at this, let's go to the document, Cam. The time that you would see a problem like this in reality, thinking of algebra and more algebra and more algebra, I've never seen anything that screwed up that I can remember. However, it tells you that you're going to do exponents and radicals. There's no parentheses. So the idea is you go through and hunt for your exponents first. And so if I do that, then clearly I'm going to take this 3 and square it to get 9. That'll be my first step. Then after I've done that, then I go through and take the square root next. Hence, exponents, then roots. So you would have a 5 there, as you see right here in the solution. So if I slide that over, you can see how we've rewritten it from the first to the second step, and then finally to your next step. And then as you go across, do the additions and subtractions in the order they come. So 16 minus 9 is your 7, add the 3, and you get 10. That is the classic approach, full solution. Now that's what you would expect to write on your page that you do the problem. That's what Larita should be seeing. That's what I should be seeing. What you'll probably be asked to do is enter the answer. Okay. Now, if you're thinking of, please excuse my dear Aunt Sally, you just have to understand that radicals with exponents get done. The problem typically is what do you do, as we come back to the problem briefly, when you get down to something like this, what is your order of operations? And that's the way I always presented it in algebra class and said, look, if you have exponents, you have to understand they get done and you simplify radicals. But you can't give something that's too convoluted. Germ days may work for you, and I don't object to it, but nobody else typically has used it. It says many people do, which means this person writing the book and maybe the students he has. That's many. He could have said a number of people do, which means he does it. If it works for you, go for it, but don't belabor it. The next problem is a little more realistic in example 4. Okay, I don't have it quite where I can get it there. Okay, bottom of the page. This is where you have a 3, and it's falling on me. Let me raise it up and hold it. We have a 3 out in the front. We have parentheses. We have an exponent. So what are you going to do first? Okay, you're going to do the parentheses. Coming down, I think you can see where that's been set up for you. Then you do the exponent. Then come through and do the multiplication. That's where you get the 9 at the bottom of the screen. And you do the division, giving you the 4. And then 34 minus the 4, giving you 30. Now, coming off there. At this point, since we are working with whole numbers, if you get a negative in your problem, a negative number, you know you screwed up. But that's a temporary condition. Because in 2-1, the end of the week, we will have introduced sign numbers, negative numbers. So just for the moment, if you are getting either a fraction or a negative number in your answer, that means something went wrong, because these answers should all be whole numbers, 0, 1, 2, 3, 4, and so on. You don't usually have that as a kind of correction that you can do. Is there any question on that part? Okay. Now, one of the things that's done on page 56 that I was noticing this morning as I was looking at this is something I want to share with you because it is part of algebra. It's a very important part of it. It's the distinction between these two parts. Let me show you what it is. If I look at this, there is no shortcut here. You take the 3, you take the 5, and you get the 8. Okay, so this cannot be abbreviated in any fashion whatsoever. Agreed? But look at this one now. If I have the square root, let's slide over just a little bit, please, Jonathan. If I have the square root of 9 times the square root of 25, okay, well, this turns out to be a 3. I'm going to use, for the moment, the times symbol. We have a 5, and this becomes 15, correct? But what's important for you to realize that this will also give you that answer. That is, the product of a radical, or two radicals, is the radical of the products. The product of two radicals is the radical of the product. Now, the thing inside is called a radicand. These are the radicands. To put it in the usual language of algebra like we do for the properties, it is saying the square root of a times b is the square root of a times the square root of b. That's one of those things that we think of as a theorem, like a property we had, but this one we could prove. But the point being, you have this choice. Sometimes it's to your advantage. Now, if I look at this, 9 times 25 is 225. So the square root of 225, remember our shortcut? 15 squared, you take 1 times the next higher number, which is a 2, and put a 25 after it. So this comes out 15 also, and you need to realize this is the choice you have. That's going to be important in algebra for you, because we will factor something like 225 and work reverse. That is, you start here, you don't remember this, you factored into two perfect squares that you do remember, come down here and get your answer. So when I simplify expressions inside a square root sign, I will use this property very often to simplify. And I'm going to show you an illustration here that goes beyond where we are at the moment. But if I gave you the square root of, I'm going to take a number here that I can use. Let's see. I'm going to take the square root of 21 over the square root of 3. So I have a quotient. Now, this is going beyond what this text is doing at the moment, because these are not perfect squares. However, I think I can make it a little bit easier if instead of that, just let me think for a moment, why don't I do, instead of 21, I can make it work the way I want. I'll make it a 12, if you don't mind. Now, the point being, I can write the square root of 12 as the square root of 3 times 4, which is over the square root of 3. But by using this property here, look what I can do. Now what can be done? Look at the monitor if I'm in your way. I can cancel the square root of 3 with the square root of 3. I'm left with the square root of 4. The square root of 4 is 2, and I'm done. I need to have you slide over, Jonathan. Thank you. Okay. Get the idea? Now, that we do in an algebra class. You aren't seeing why this is important up here. Now we need to slide over a little bit to the left. This is important because, slide back over, I can do this. Now, remember, the square root of 2 we said was irrational. Did that last semester. Can't be written as a fraction. The square root of 3 is irrational. And I have an irrational number in the denominator. By playing this game, the denominator technically is a 1 now, which is rational. And so we say we've rationalized the denominator. And that becomes a very crucial point of algebra. So in passing, the text is, as we slide back over, trying to emphasize that I have this choice. I can take that product inside and rewrite it as the product of the two radicals. Okay, now you have to be cautious. And again, every step we take is like, how do you avoid getting messed up or making a careless kind of assumption? If I want to take the square root, this is what we've been writing. You need to understand that there are other roots I can do. So if I say the square root of, let me think, 64, you know that's 8, because 8 times 8 is 64. But if I want to make sure you understand that I'm taking the square root, I put a 2 up here, like squaring a number. Because I can do what's called a cube root by putting a 3 up here, and I can ask you, what number can I write as a product? 3 times I get 64, and the answer is 4. 4 times 4 is 16, times 4 is 64. So this becomes a 4 here and becomes an 8 here. Not all roots are square roots. If you don't see this index written, then it's understood to be a square root. But don't get in the habit of saying root 64 like root 66, like you're in a highway somewhere. Because when you say root, it is not clear that you mean square root or cube root. So if you're going to say root, you say square root. Don't just say root 64, square root of 64. The language that you use is very critical, because if you use it sloppy, then you could end up getting an idea in your head that shouldn't be there, Michael.
Is there any other roots?
Oh yes, we can have third root, fourth root, fifth root, sixth root, seventh root, any root. The square root and the cube root are the two biggies. We talk about the nth root. No, nth. Just a general root, where n can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Yes, Richie? Well, it's not really an exponent, it's an index. Yeah, that would say the third root, where this is the second root or the square root. So third root means cube root, second root means square root. You'd say cube root. Yes. Okay? I could say sixth root. This is the cube root. What is the sixth root, since we're at it?
2.
Good answer. Because 2 times 2 times 2 times 2 times 2 times 2 is 64. So the sixth root of 64 is 2. The cube root of 64 is 4. The square root of 64 is 8. Who do we appreciate? Okay. Now what you're reacting to a little bit is, that's a lot of roots. And it's sounding very uncomfortable. And it is. But that's why they're introduced in a pre-algebra, so you can get uncomfortable now and comfortable later. Before we end, just a reminder, and this is a neat one. We've said the square root of a value, okay, implies that the value in here has to be a positive number. Okay. So if I had a negative 64 in here, you say cannot do. It is not a whole number. It is not a rational number. It is not an irrational number. It's imaginary. We will rewrite this in the following way, and I just need to have you understand that we do allow ourselves to deal with negative numbers inside And we call this the letter I. Little I. So we have iPods, iMacs, and I numbers. The square root of -1 is called I. We just make that agreement. Like in Alice in Wonderland, a rose by any other name, or Shakespeare. A name means what I mean, and nothing less and nothing more, or a rose by any other name is as sweet. So that takes Lewis Carroll and Shakespeare in all one fell swoop. I is the square root of -1, so this would be 8I for an answer. And the reason I bring this up, you take the cube root of -1, and you can do that, because -1 times -1 times -1 will turn out to be a -1. So we can take some roots of negatives, not other roots. Can't leave the roots without making those comments. And I'm taking you quite a ways into material in the future, but this is worth taking time to do. So I'm going to go back center, Jonathan, so you know where I'm headed. We've done that. Fortunately for me, with what I've wanted to say now, I've got time to talk about things like what I just did without chewing our time up. I want to remind you, this is on page 56. Okay, and what I'm looking at there is a square root of 9 plus the square root of 16. There is no shortcut here. I can't add the 9 and the 16 and get 25. It won't work. Try it. If you added the 9 and the 16, you get 25, and the square root would be 5. Doesn't give you the same answer. So you cannot say the sum of the radicals is the radical of the sum. That does not work. And that's what's illustrated here. Okay, so just a warning is the way it's given to you, and that one is very important. This does not work. You will die if you do that. Don't try this. The radical of the sum is not the sum of the radicals, but the radical of the product, Jonathan, coming off there, the radical of the product is the product of the radicals. That does work. Now, fortunately, we've already done what's on page 57 as we go there. The mean of a set of numbers. That's like you find your test average. You just add everything up and divide by how many. And so the procedure that's given here is calculate the sum and divide the sum by the number of values. I'm not going to leave it there. I need to have you on the sideboard, Jonathan, please. Because notation time. Might as well learn some Greek while we're at it. Don't need to wait until Math 90 to do that. Okay, there's a new symbol for you. It looks like an M on its side nearly. It's called big sigma, like big owl. Sigma, it's a Greek letter of the alphabet. It says add 'em up. It says find the sum. If you're going to learn what the mean is from the statistics, then I want it to be learned correctly. So if I have these numbers, and these are test scores, so you had a 95, a 100, and you had a 90. Okay? Yeah, that'll work. 3 scores, and you wanted your test average. You'd add those up, correct? So we could call this your score for the first test, T1. The second test, T sub 2. The third test, T sub 3. These letters down here are called subscripts. Just like exponents are superscripts. So this says T sub 1, T sub 2, T sub 3. So if I want you to add up these test scores, I can say take the letter T sub I. That's the index. Start with 1 and go to 3. That notation means T1 plus T2 plus T3. You need to know that. Now, we usually don't tell you the index. We just say, find the sum of your test scores, sum of t, and that means this. Understood. Just add them together. It's the notation. Sigma means add them up. So this says add up the test scores. Then you're going to divide by how many test scores you have. So this average, we want to put over 3, correct? We add the scores, put it over 3. So this says take the sum of your tests, divide by the number of tests. And we're going to call that t-bar. The average of your test scores. No, the bar says the average. When I put the bar over the t, that says I want the average called the mean. Now, this is exactly what we do with your tests. It's just the language we would use. When you look at books talking about the mean, they will say x bar is the sum of the x's over n. And that's my definition for the mean. Yes, you do. You truly do. I said that's where you see the notation. I'm doing it here. So if I do it, you know it. Yes. Yes, it's important. Yes, you could, but you won't. You will remember this because that's the way I'm going to ask it on a test. Give you some data and say, find x bar. What was the median called? X squiggle, x tilde. Okay, so x tilde is the median. It's the middle number. And that's covered in this section so that you have an even amount of data. So if I look at these 3 scores, let's slide over just a bit, and you list these in order, then you'd have a 90, a 95, and a 100. What's the median of my 3 scores? 95, because if I list them in order, this turns out to be the median. Now, what is the mean? Well, if I add this, this is going to be 285 divided by x bar is 285 divided by 3, which is also 95. And I rigged the problem. Is the mean and the median, or will the mean and the median always be the same? And the answer is no. Definitely not the case. Okay. What happens if I have an even amount of data? So let's say that we had 4 tests for the semester, and I had a 95, a 100, a 90, and then you took the last test and partied too much and dropped to an 80. Okay, so the question, if these are my test scores, what is the median going to be this time? So I'm going to look at x tilde, and I'm going to have an 80, a 90, a 95, and a 100, correct? The median is this value between 95 and 90, which is 92.5. What's the value halfway between 90 and 95? 92.5. What is the mean? Well, if I add these up and think of finding the sum, I get a 5 here, no carry. Here I have 1826. That makes a 3 here. So I have x bar is going to be 365 over 4. And what do I get there? Well, 4 into 36 goes 9. No remainder. 4 goes into 5 one time with 1 left over. So my x bar is 91.25, whereas my x tilde was 92.5. And these are problems you're doing in this section of the book. You're finding medians and means and order of operations in section 1.5. Now the difference in what the book is doing and what I'm doing, let's slide back over, is this notation. I expect you to know that that is the notation for the mean. the sigma x over n, which means add up all the values and divide by how many you have. If you just think of what you do for your test scores, when you find the average for your tests, it's exactly what you do. Okay? So I'm going to leave that on the board. And I'm pushing you with language a little bit today. Just a little. There is no formula for the mode at all, and no symbol for it other than to note you have a mode and you write it out, M-O-D-E. Usually we're more interested in you have more than one mode. So if I give a test in a class in which the students aren't prepared, let's take a Math 20 in which the students do not take Math 10. My distribution of grades will usually have two different modes, two different frequent values. So for the group who had 10, they will tend to center at 80. For the group who didn't have 10, they will tend to center at 50 or 40. Called bimodal, and that means you're in trouble. Two different populations. When you've had 10 and you're prepared, you do well. If you don't, it's a crapshoot. Okay? Question, Jessica? Mean or the median? When you do the mean, I'd like to see the formula. Formula, substitution, and answer. You know we've been there before, Marisol. We say x bar, not x with the line on the top. So you say x bar, like a coffee bar. Sigma x over n. Yes, you're doing the language well. The median is the middle number when the data is sorted. When your numbers are sorted, the middle number is your median called x tilde, or x with the little squiggly line. Yes, Michael?
What is the x next to the sigma?
The x next to the sigma.
X bar
You mean when I say sigma x?
Yeah.
The x is understood to be a letter used to represent your numbers, like test, T for test, like a formula. And so T sub 1 means your first test score. T sub 2, your second test score. Well, when I don't have a letter representing what I'm measuring, test, it's easy. I'll use the letter T. But what about maybe the number of interceptions that I see a quarterback throw in the games during the season? Well, I could use I sub 1, I sub 2, but usually we don't do that. We just say, here are my numbers. X sub 1 means the first number. X sub 2 is your second number. X sub 3 is the next number. What I want you to realize is that there's a difference between subscript and superscript. The super above, the sub below. Okay, so the superscript is an exponent. The subscript is an index, like the index on the radical sign, but it tells you which piece of data you're looking at. So we use the letter x as a dummy variable to represent numbers. So if they aren't test scores and they're just generic numbers you have, x1 will be the first one, x2 the second, x3 the next, and so on. James. The mode, as Robert said, there's no language that I'm familiar with notationally that tells you the mode. Now, I mentioned to you a moment ago that I don't have a symbol for the mode. And I want you to understand, for the median, some people use a big M. For reasons I don't want to explain at the moment, that'll get you into trouble. Don't do it. So use x tilde. Okay? Now, one more comment. If you want to know where the median's located, it's n plus 1 over 2. N is the number of data. So if you go to the sideboard again, Jonathan, with the camera where we were, and I look at those 4 values, just exactly where you are, the 4 values mean n is 4. I have 4 pieces of data. So if I look at my list of data here, I have these 4 pieces of data. N plus 1 is 5. 5 over 2 is 2.5. and I'm at the 2.5 position, halfway in between. So I find the middle value between these two. That's how I find the median. Understand, location is not value. Now, in real estate, location is everything. For the median, location just tells you where to find it. It doesn't tell you what it is. Michael.
So that expression,
That expression.
that formula right there with the ET, yeah, that one.
Slide over, Jonathan. Thank you. Keep going. That's not ET. This is not an extraterrestrial. This is sigma T.
Okay.
Big sigma.
Isn't that the same as EX over X?
Not EX. Sigma X. You can't say E. Yes, they are the same. It's just whether you want to call it T or X. Okay? But it is not E. It is sigma. Okay, not a mouse squawking. We got it? Richie. The average of the test scores. When you see the bar over the letter, it says you're finding the mean. Now, we can say average, but there are two averages. There's a mean and a median. And technically 3 if you talk about the mode. But I don't really want to know about the mode unless I have more than one of them. Yes?
So the T would represent the test? Like
T
that?
standing for test, like in formula. L for length, W for width, T for test.
So we would use
X is generic. I've got numbers. We'll just call them X's. It's like you don't know how to spell your name, you put an X. You don't know how to represent the number, you put an X.
all right, so you use the T right there.
Because they were test scores. I could have used an X, which I did. Now this reminds you of the T-bar they had in the Pontiac, in which they had the T-bar and you took the two sides off on the top, right? Okay, same idea. Yes, Robert?
So does sigma represent a number or?
No, sigma represents an operation. Add them up. It's a sum. S stands for sum. Sigma is the Greek letter for S. Big S, big sigma. Unless the only other place you'll hear this is in sororities and fraternities. Sigma, gamma, tau.
And then what is the,
What is the?
like, what's the purpose of them using those terms or symbols?
The purpose of the notation. Oh, you couldn't have asked a better question. I'm going to quote Bertrand Russell. Whoever that is, you need to Google Bertrand. Okay, Bertrand Russell, philosopher, mathematician. He had this statement: a good notation has a subtlety and suggestiveness that at times makes it like a live teacher. Good notation will save you. It will make mathematics have clarity that otherwise is lost. Notation replaces words. Words become confusing. Notation isn't. Embrace notation. Again, a good notation has a subtlety and suggestiveness. Well, let's see what else I need to do. We revisited the median. We talked about the mean. We've talked about the mode. We've talked about radicals. We've talked about germ days with TM, text messaging. And that's pretty much the section. So let's look at a couple problems, which I don't often have time to do, and let's just see what fun we could have. Where we can just see the problem. I'm looking at number 41, if I can get the camera to cooperate with me. Let's see. 41, yes. Okay, there it is on the screen. 41. So we have 4 cubed, or 4 to the third. Then we have a minus 5. And notice we have parentheses and brackets to confuse the issue. So I have a bracket and a parentheses inside the bracket. So you take the outer ones first to designate where you're going and then do the inner one. So you locate the big one and go inside. That's not explained when you see the G for grouping. So you're going to take the smallest parentheses here. Notice I could have, and this is sometimes done, use a parentheses for both. It's just getting confusing. So I could have done parentheses, parentheses, 28 minus 4 parentheses divided by 2 cubed parentheses. but we use brackets so you don't get confused. What are we going to do first? That little one inside here first. Yep. Parentheses first, so that's going to be a what? A 24. Do the exponent, which is an 8. So I could replace this. This is an exponent. So I would be inclined to say 4 cubed, which is what? 64 minus 5 times 24 divided by 8. I would do that inside, and then I'd have the 100 divided by 25, which is a 4. So I'm going to try writing some of that on the board going back and forth. And there is no one best way on something this messy, but it's a nice one to focus on. So my first step was 4 cubed. Let me write out the next. 5 bracket parentheses. I could have done parentheses, parentheses, which is what you do in spreadsheets. You don't designate parentheses to brackets. Close the bracket. And notice in the one above, there's even that little bar. See, you have a parentheses, bracket, and braces. Looking at 39, you have parentheses, brackets, and braces. Then I have plus the square root of 100 divided by 25. Okay, so now, coming to the board. This is 64. Do that, then the minus 5. Leave your bracket in. This becomes 24 divided by 2 to the third, which is 8. Bracket there, plus square root. So I'm going to do what's inside there first, which is going to give me a 4. Now, that's not the only way I could have done this. Michael.
So you do the parentheses, inside the parentheses first?
Yes, the innermost parentheses. The innermost of the innermost. Okay, next. I'd leave this one alone. Leave that alone. Get this taken care of, where I now have a 3 here. Now that means multiply when you have a 5 outside the bracket. It's understood, multiply. Then plus a 2. Then what am I going to do? Multiply next. So 64 minus a 15 plus a 2. Now, I could go ahead and say 64 minus 15, which is 49, plus 2, which is 51. In order given. Add and subtract in order given. That's why in the text they put that arrow over the AS in Aunt Sally. James, I think, then Michael, and then Kim. Okay, Michael? Yeah, I sometimes, personal choice, take the positives, add them together, and then subtract off the negative. But I don't want to go there yet. Kim? Yes?
When you bring the 24 down, can you just punch 2 around it?
I could, but nothing's lost or gained.
You have to multiply it.
No, because I have a division inside the brackets. Simplify the brackets. Next. It's fun. It's a lot more interesting than just adding a bunch of numbers. Can we do 39? Let's look at 39 for a moment. And, no, in the book, there we go. Now, understand, I'm looking at the worst of the worst. So this is probably not the fairest thing to do but I'm looking at the ones that I think are going to give you trouble. I think I have time to look at 39. So we have, help me out here, it's a brace, right? Then an 18 minus a 4, bracket 21 divided by, parentheses 3 plus 4, parentheses bracket brace, yes, plus 3 times the square root of 16 times 4. Yeah, and I'm going to put an X there, although he puts a dot. Okay, so as I go to the board, what I'm going to do is take the inner part here most first. So I'm going to do the 7 here. So I have a 7 there, so this is a 21 divided by 7. And I'm abbreviating this because of time. That becomes then a 3. So I really have brace 18 minus 4 times 3, and close the brace off plus 3 times the square root, and I'm going to put 16 and 4. Do that because that makes it easier. So this gives me 18 minus 12 inside, which is a 6, plus a 3 times a 4 times a 2, which is plus a 24, which means I have 30. Okay. No, I realize that was fast, but look at it. See if you can follow it, because I'm down to less than 2 minutes. Okay, and it'll stay up on the board after we close down. So I need to go to the point of where we close down. We've been listening to Crosby, Stills, and Nash. And what is your close in this, Jonathan?